Perfect. Okay, hello, my name is Solnik, and together with Daniele Piscitelli, we would like to convince you today that studying human interpersonal interactions is important in robotics. Two-person interactions are frequent in everyday activities, and in such actions, people coordinate their motor behavior since the stability of joint motor performance is crucial. In human-robot interactions, coordination and stability of the performance are also critical to accomplish a manual task. The abundance of motor elements offers the central nervous system an opportunity to organize them into task-specific groups called synergies that stabilize performance variables. This chicken video is an excellent example of how motor elements are organized into synergies that stabilize the bird's head. Similarly, when holding a glass of water, hand moments need to be organized into synergies to maintain the rotational equilibrium of the object. And we use the uncontrolled manifold analysis to quantify performance stabilizing synergies by computing two components of intertrial variance that do and do not affect a specific performance. So in the first experiment, we investigated the force stabilizing synergies in accurate multi-finger pressing tasks under visual feedback only. Subjects produce a time profile of total force by matching a target force trajectory on the computer screen. The two-person performance was characterized by higher force stabilizing synergies, suggesting that providing only visual feedback is sufficient to organize synergies between two people. In the second study, we mimic a common task of passing a glass full of liquid between hands with both visual and haptic feedback. Subjects transfer the instrumented handle from the right hand to the left hand or to another person while keeping the handle's position and orientation stationary. Contrary to the previous experiment, stronger performance stabilizing synergies were observed in one-person condition. Sorry, this is my Roomba just turned on, so. And interestingly, the bimodal shape of relative phase difference between hand forces in two-person condition might be related to the leader-follower relation and needs to be explored more in future studies. So in this third study, we address dynamic manual actions that closely resemble real-life situations. We tested if synergies can emerge during an unstable manual task where inaccurate force production leads to failure. The instrumented board was balanced on the rotating cylinder, and subjects were asked to keep the board horizontally while cyclically moving it between two targets. The task was completed in both conditions, but interestingly, again, moment stabilizing synergies were higher for tasks performed together. So in conclusion, our results show that humans do change their control of manual skills when interacting with another person, and the motor behavioral changes depend on the type of action. And understanding this aspect of motor control that includes error compensation, organization of synergies, leader-follower relationship could aid the robot's design in expressing more natural, human-like behavior and increase the motor capabilities. Thank you.